The Internet of Things and robotics are highly complementary fields. IoT systems can provide environmental information for improved autonomous decision-making, while robotics provides the means for IoT devices to influence the environment. However, existing systems in IoT and robotics are largely incompatible. While robotic development is largely unified under the robot operating system, the IoT ecosystem is highly fragmented and vendor-locked. This makes interoperability between the two systems difficult to implement.
Our project aims to bridge IoT and robotic systems using open source technologies and has three major components. A sensor endpoint comprised of easily accessible off-the-shelf hardware and open source firmware. A cloud component to store and serve data to robotic clients, and a ROS library to hook into existing ROS systems.
Here we take a closer look at the endpoint hardware. The main components are an ESP32 microcontroller, an e-ink status display, and several digital and analog sensor interfaces. In this video, we have a potentiometer, color sensor, Hall effect sensor, and tilt sensor connected. The ESP32 collects the sensor data and sends JSON messages over MQTT to AWS. The ROS application then identifies the endpoint using the QR code on the status display and uses our ROS library to request data from AWS and construct an augmented reality overlay on the camera feed. This is an example field application of our project. Here, a dual-armed mobile manipulator is preparing to conduct a teleoperated valve turn. On the left of the user interface, you can see a wide-angle view of the task area. In the lower right view, there is an augmented reality overlay of data from an encoder attached to the wheeled valve. While in the upper right, we plot the historical encoder data over time. In future systems, we hope to see fully autonomous decision-making based on current and historical IoT data. And while the current iteration of our project is not suitable for deployment in commercial or industrial environments, we believe that it opens up new opportunities for researchers in topics such as machine learning, co-robotics, and distributed systems, among many others.